Hello, everybody. I am Rabab Alomairy, a PhD candidate at KAUST. Welcome to my light talk, which is about Al-Fursan. It's a stand for abstraction layer for standardizing APIs of task-based engine. Here it is, the outline of my talk. First, motivation. Recently, task-based runtime systems are constantly evolving to handle parallelism in flexible and productive manner. However, lack of API standardization makes it difficult for software developers to embrace these changes. Therefore, Al-Fursan here to rescue. Al-Fursan has 5 goals: standardizing the API of task-based runtime system, relying on a lightweight abstraction layer, supporting different hardware architecture, improving user productivity and code portability, leveraging runtime interoperability. This figure shows Al-Fursan software stack. It exposes a common API for the end user and supports different backend API for the 4 supported runtime systems: StarPU, QUARK, and OpenMP. Here it is one of the important capabilities of Al-Fursan library, which permit to make the various runtime options coexist for the benefit of the application. This figure highlights the series of internal events of this feature. It describes the situation of switching between StarPU and QUARK. StarPU running with 4 CPU threads and 2 GPU, while QUARK running with 3 CPU threads. This pseudocode highlights task-based Cholesky factorization using Al-Fursan. Al-Fursan initializes the runtime scheduler by calling Al-Fursan init and terminated using Al-Fursan finalize. Each of the computational kernels can be defined using Al-Fursan insert task API, and the different data dependencies and task options can be expressed using Al-Fursan input, Al-Fursan output, Al-Fursan priority, API, and so on. To evaluate the performance impact of Al-Fursan, we consider different workload characterization, and we run on 5 architecture, as you can see here in the table. For a compute-bound workload, we choose to measure performance in terms of gigaflops per second, as shown here in the y-axis on the left figures. The x-axis shows different matrix sizes on all figures. On the top left plot, as expected, this Cholesky operation permits to hide the overhead not only of the native runtime, but also of Al-Fursan abstraction layer. In the bottom left plot, thanks to the unified API of Al-Fursan, same interface can enable Cholesky operation to run on a GPU execution space. For a memory-bound workload, y-axis shows time to solution. In the top right plot, since tile-low-rank Cholesky factorization is memory bandwidth bounded, the overhead incurred by Al-Fursan on each runtime can be explicitly noticed, and it seems acceptable up to 10%. On the bottom right plot, the same API of the low-rank representation can be ported into distributed memory architecture, such as Cray XC40 here. Runtime interoperability result. These plots illustrate performance impact of switching runtime at a runtime using generalized symmetric eigenvalue problem. The figure in the top left shows performance breakdown of various computational steps of this workload. The x-axis shows different tile sizes for 45K matrix size. Al-Fursan implementation of this workload outperformed Plasma implementation by more than 35% by switching between StarPU and QUARK. In the remaining plots here, Al-Fursan outperformed state-of-art implementation of eigenvalue problem and achieved almost a 2-fold speedup on the system equipped with 8 V100 GPU on the bottom right plot here. This figure further analyze the overhead of Al-Fursan and identify where it occurs. Here you can see the impact of Al-Fursan on different phases, such as task insertion, task unpacking, and the runtime management overall for the 4 supported engines. Conclusion and future work. Fursan is a lightweight abstraction layer. As a future work, we are aiming to increase Al-Fursan scope by supporting more runtime systems, such as ONBSS, developing Rabab for other programming languages, such as Python and Fortran. Our software is public. Please feel free to download it. For more information, you can read about our paper in TPDS journal. Thank you.